Right, in section 13.1, we'll be looking at antiderivatives. Let's go ahead and look at the first example together. What is the derivative of f of x is equal to x squared? What's the derivative of x squared? 2x. What's the derivative of x squared minus 3? 2x. And what is the derivative of x squared plus 4? 2x. What do you notice that is similar? They're all the same, right? These are all the same. That is correct. So, and I've graphed all three of these functions over here. What you should notice is that if I pick a point, let's say I pick the point on each of these where x is equal to 1, and then I draw the line, that is the tangent line, through each of these. Do the best I can here. If I've done it right, they should all be parallel. I don't know. That's pretty close. And that's not just true at x equals 1. That's true at all of the x's. It's because each of these functions have the same derivative. Since they all have the same derivative, they all have the same slopes. So, So that leads us to the definition of antiderivative. The antiderivative, push that up on that. So, and what we say is this: big F is an antiderivative of little f of x if big F prime of x is equal to little f of x. So if you can find a function whose derivative is f of x, then that function is called the antiderivative of little f. Now go back to my example here. What is an antiderivative of 2x? Well, you might say that it's x squared, or you might say that it's x squared minus 3, or you might even say that it's x squared plus 4. All three of these are antiderivatives of 2x. So all of these are antiderivatives of 2x. So that makes things sort of challenging, is when I ask you to take a derivative, there is only one right answer. When I ask you to find an antiderivative, there are in fact infinitely many answers. So we sort of come up with a way of handling all of this. What we'll do instead is acknowledge that you could add any number to the end of the function to get any antiderivative. And so what we say is the antiderivative of 2x is x squared plus c, where c is a constant number, and you just have any constant that you want to use. But this would be the general answer to the question, what is the antiderivative of 2x? It's x squared plus c. All right, so antiderivatives, you're just going backwards. We'll go over the rules here in a moment. But as long as you have a firm understanding of what an antiderivative is, then we're okay. It's just a number that you take the derivative of in order to get the function that you've been asked about. So example 2 says, find all antiderivatives of 3x squared. And let's change this problem here as well. Let's change this to 3x squared down there. But part A first. Find all antiderivatives of 3x squared. So what function do you take the derivative of in order to get 3x squared. X cubed. Now we want to represent all functions that would have this as a derivative. So we say x cubed plus c. And then part B, find the antiderivative of 3x squared that passes through the point 2, negative 1. So if we say that this is y equals x cubed plus c, there will be only one value of c that looks like this function and still passes through this point. To find that c, we just plug in the point, evaluate at 2, negative 1. So we have negative 1 is equal to 2 cubed plus c. And so that's negative 1 equals 8 plus c. So c is equal to negative 9. So the particular antiderivative of 3x squared that passes through the point 2, negative 1 is y equals x cubed minus 9. So just like we had above, if we have all antiderivatives of 3x squared, they're all this cube function. They're this x cubed function, and they all look the same. But they're shifted up units and things like that, right? What we're doing is we're finding the particular one that passes through the point 2, negative 1, which will be right here. And that's the one that has a vertical shift of negative 9. Yeah, it looks like that. Not quite drawn to scale. All right, and so you'll hear these terms thrown around: general solution and particular solution. All right, let's look at the next page. And that leads me to the topic of integration. So integration is the process of finding antiderivatives. The symbol for integration looks like the following. It's a little hook, and then straight down, and then another little hook. And you have to tell it what function you're dealing with. So we'll say little f of x. And then a differential plays a little part of this. You say dx. The meaning of the dx will become more clear as we work our way through chapter 13. Today, let's just think of it as notation. The d is the derivative part. The x tells me what the variable is. So this is a variable of x, f of x. And of course, this is equal to big F of x plus c, where f of x is an antiderivative of little f of x. I.e., that means that big F prime of x is equal to little f of x. But here is the notation. See if I can do this right. Rectangle. Nope. There it is. This symbol is called the integral sign. The f is called the integrand. And as mentioned, the x is the variable of integration. Now, if you had to assign and say that the integral sign looks like some letter, which letter would you say that it looks like? It looks like an S, yeah. And it comes from sum, and we'll see more of the relationship between sums and integrals later on in the week. But yeah, it's no coincidence that it looks like an S. In fact, have you ever seen the original, like Declaration of Independence or Constitution preambles and stuff like this? There was a way of writing an S back in the 18th century that looked like this. That's where that comes from. They all look the same. All right. So here's our basic formulas. Now, all you are doing is you are doing derivatives backwards. So if we have the integral of x to the nth power dx, you have to figure out what you would have taken the derivative of in order to get x to the nth. So remember, differentiation works by bringing the power to the front and then lowering the power by 1. We're going to do that process backwards. We're going to raise the power by 1 first, and then instead of multiplying, we divide by it. It's exactly the opposite. So the power here is n, so we'll raise the power by 1. That makes an n plus 1, so x to the n plus 1. And then the opposite of multiplying is division. So we divide by n plus 1. And that'll work when n is not equal to negative 1. If n is equal to negative 1, then that's x to the negative 1, which is 1 over x, which is the second case. So the integral of 1 over x is the natural log of x plus c. We need to throw in the absolute value so that the x can't be negative. And then, of course, your favorite, what do you take the derivative of to get e to the x? E to the x, so it's its own integral as well. So the integral of e to the x is e to the x. All right, let's look at example 3. What is the integral of 2x plus 3? So just like differentiation, you can do these piece by piece. So we'll start with the integral of 2x. The power on the x is 1, so we're going to raise that power to 2, right? Add 1 to the power, divide by the new power. And then 3 is really 3x to the 0. So we will add 1 to the power. So that becomes 3 times x to the first divided by 1. And then as soon as you do the integration, you tack on the plus c. You don't wait until after you've simplified everything. It goes in immediately. 2 divided by 2 is x squared, or 2x squared divided by 2 is x squared. And then 3x to the first over 1 is just 3x plus c. All right. Now some of these, you don't have to go through this process of adding 1 and dividing by the new power. You can just go ahead and do it. I think everyone knows, what did you take the derivative of to get a 3? That was 3x. So there's the 3x. And maybe even the 2x, right? What do you take the derivative of to get 2x? X squared. So it's x squared plus 3x plus c. All right, go ahead and do example 4 by yourself. Haley, what'd you get for this one? Yeah. Yeah, there you go. Good deal. Yeah. So if you saw it straight up, you can just write that out. If you didn't see it, you need to use the rule. The power here is 3. Raise the power by 1. The power becomes 4. Divide by 4. That cancels these 4s. You get x to the 4th. The integral of e to the x is e to the x. And then you tack on plus c, and you're done. Very good. In example 5, we have the integral of 1 over t minus 1 over t squared dt. What is the variable of integration? T. All right. So this one we just work with t's. The answer will be in t's. This one we need to do a little bit of rearranging. We know how to integrate 1 over t. That's one of our special rules. The 1 over t squared, we don't know how to integrate yet. So we do much of the same stuff we did before when we had the variable in the denominator. We have to move it to the numerator and negate the exponent. So this becomes 1 over t minus t to the negative 2 power. Now notice, I have not done any integration yet. That is simply algebra. So we still retain the integral sign. We still retain the differential, the dt. Now we do the integration. What is the integral of 1 over t? Natural log. Use the absolute value. So it's natural log of the absolute value of t minus, now let's run the rules on t to the negative 2. Going to add 1 to the power, so that's going to be t to the negative 1 divided by negative 1 plus c. So we have the natural log of the absolute value of t. These two negatives cancel. T to the negative first power goes back into the denominator. That makes 1 over t plus c. Incidentally, how would you check all these answers to see that you're getting them correct? Take the derivative. The derivative, yeah. And the derivative of c, the derivative constant, will be 0, so you never have to worry about that. If you take the derivative of these parts and see that you get that. When you take the derivative of the natural log of the absolute value of t, just ignore the absolute value stuff. Questions over example 5? So what is the exponent in this piece? Negative 2. Add 1 to get negative 1. So that's the new power, and you divide by the new power. Yeah.
How do they cancel out?
The negative and the negative?
Did they cancel out the exponent or the
No, just these two right here. Those made the positive. And so it's really plus t to the negative 1, right? Maybe I better draw my pluses a little better here. Plus t to the negative 1, which is then 1 over t. Because t to the negative 1, t goes down to the bottom. T to the first, like that. Okay. Let's look at example 6. We need to do the integral of x to the 4th minus 5 over x squared. We have x's in too many places. There's a fraction, it's not on the baseline. So we have to do some algebra first to fix that. So we're going to split it up. So it's going to be x to the 4th over x squared minus 5 over x squared dx. When you simplify this, x to the 4th over x squared is x squared. I can't simplify really the 5 over x squared, but I can write it in a form that I can integrate. I'll do that by moving the x squared to the top. So that becomes minus 5x to the negative 2 dx. Notice I still have the integral sign, and I still have the dx. And now we integrate. All right, what's the integral of x squared? So raise the power by 1, divide by the new power. So it's x cubed over 3 minus 5. Raise the power by 1. So negative 2 plus 1 is negative 1. Divide by the new power, negative 1. I have finished the integration, so I immediately write plus c. And then simplify what you can. So this would be x cubed over 3 plus 5 over x plus c. Questions? All right. Go ahead and do example 7 with your partner. First, what is the variable of integration? W. And this is the cube root of w. How do you write that as a fractional exponent? What is it? Yeah, w to the 1/3. All right, go ahead and do that one. Third denominators. Third denominator. And don't forget to clear the denominators. Okay, let's check it. So this would be 8w to the 1/3 dw. So to integrate, we raise the power by 1. What is 1/3 plus 1? 4/3. What's the shortcut for doing that? Add the numbers together. 3 plus 1 is 4. That creates the new numerator. Retain the denominator. Divide by this new fraction. Plus c. Now we must clear denominators. When I say clear denominators, that refers to a little fraction inside of a bigger fraction. And you multiply top and bottom by all of the denominators from the little fractions. So we're going to multiply by 3 over 3. We can do that because 3 over 3 is equal to 1. When we do that, the 3's on the bottom cancel, but the 3 on the top merges with the 8 and becomes 3 times 8 is 24. W to the 4/3 over 4 plus c. And then 24 divided by 4 is 6. Six W 4/3. Well, let's write this one as a radical here. So it's 6 cube root of w to the 4th plus c. There we go. That's a good one. For now, yes. Yeah. This is a thing called indefinite integration. And eventually we will get to definite integration. Yay. And then it will have an actual retail answer. All right, Raquel. On example 8, what's the first thing you would need to do to begin the process of the integration? Well, you can't do it here because it's times here. So what do we got to do? We've got to combine. Combine these first. So what would you do? Okay. All right, go ahead and do that one. Yeah, you can't. You know how there are special rules for products and quotients and all these sorts of things with derivatives? Okay. Same thing with intervals. You can't do anything unless it's just straight line stuff. So if it's x squared times something with other stuff, you got to get it in the straight line first. Now, you're still exhibiting the integral sign, which you should not do. Oh, you are exhibiting the integral sign. See, once you integrate, you don't. It's like a limit. Actually, it is a limit. I think it. Okay. Now you need to exhibit the integral sign. Raise the power by 1. Yeah, keep the 4. It may cancel, but it may not. Okay. Yeah. Take that. Raise the power by 1. By that new power. By that new power. Okay, good. Now integrate. Take that power, add 1, divide by the new power. You got it. That's it. What? There's the new power there. You need the new power here. Well, that's an exponent. You can't cancel an exponent. That's a number. Let's see what you get. All right. So raise the power by 1 makes x to the 5th divided by 5. Raise the power by 1 makes x cubed divided by 3 plus c. And that's it. Questions? All right. All right. Ooh, look at this one. Find the antiderivative that satisfies these equations. dm dz is equal to z squared minus 4 over z, and m of 1 is equal to 2. So first off, we need to find the m function. What is the variable on the m function? And how do you know? It's z, right? So we're going to end up with m of z. And how did you know? Where? There's a better place to look for it. Right here. This is the derivative of m with the variable z, right? Just like we had dy dx, that was a y function with x's, or we had df dt, that was an f function with t. This is m of z. So look for this notation to tell you what the variables are. Now, in order to find the m function, this is the derivative. So the m function would be the antiderivative of what we're given. So we need to integrate z squared minus 4 over z. So does everyone understand the relationship here? This is the derivative of m. So to find m itself, we need to take the antiderivative, take the integral. Now, if I just do it like this, I'm going to get plus c. This piece over here is going to tell me exactly what the c is. And that'll tell me the specific m function to use. They call this piece over here the initial value. All right. So we're going to have the integral of z squared over z minus 4 over z dz. That's the integral of z minus 4 over z dz. What is the integral of z? What? Z squared over 2. What is the integral of 4 over z? For ln absolute value of z. Yeah. So z squared over 2 times 4 ln of z, absolute value of z, plus c. Now that's our general solution. We need the particular solution. So I'm going to plug in m of 1. I'm going to evaluate 1 inside the m function. So m of 1 would be 1 squared over 2 minus 4 times the natural log of 1 plus c. That's what m of 1 is. Now, what should this be equal to based on the initial value? It should be equal to 2. Notice I can now solve for c. 1 squared over 2 is 1/2. The natural log of 1 is 0, so all this is gone. So plus c is equal to 2. So c is equal to 3/2. And then your answer to this is going to be the m of z function. So it's going to be z squared over 2 minus 4 natural log of z plus 3/2. By the way, did you enjoy this one? There's a whole class you can take doing this. You know what it's called? Differential equations. You just solved your first differential equation. When you get home tonight, you should tweet that. I just solved my first differential equation. Have y'all heard of differential equations before? Okay. All right. Example 10. The rate of change of monthly sales of a new spectacular 4-slice toaster unit is given by s prime of t is equal to 120 t to the 1/3 power. And of course, s of 0 is 0. Where t is the number of months since the toaster was released to market, and s of t is the number of units sold each month. Find s of t. When will monthly sales reach 1440 toasters? All right, so we're looking for s of t. We're given the derivative. So how do we find the function given the derivative? Yeah. Yeah, take the antiderivative. So we have the integral 120 t to the 1/3 power dt. Integrate. So this is 120 t. What's the new power on the t? 4/3 divided by the new power plus c. Clear denominators. So we're going to multiply by 3. So it's going to be 360 t to the 4/3 power divided by 4 plus c. And 360 divided by 4 is 90 t to the 4/3. So that's s plus c. So that's s of t with the c. We will now use the initial value to solve for c. So s of 0 is 90 times 0 to the 4/3 plus c equals 0. And so what's c? C is 0. Now, I'm going to tell you, c is going to be 0 a lot of times. Never take it for granted that the c is 0, because you may have some other weird function like an e or a log or something, and then it won't be 0. All right, so you always have to check it. But you're going to do enough of these where you think c is 0 all the time, and it's not. All right, so the function is s of t is 90 t to the 4/3. Then the question is, when will monthly sales reach 1440 toasters? Is that s or is that t? What does t represent? Read the problem. T is months. So what is toasters? S is toasters. All right. So 1,440 should be s. So 1440 is equal to 90 t to the 4/3. The question asks for when. When is a time period, so that's asking for the number of months. And so we solve this equation for t. So 1440 divided by 90 is equal to t to the 4/3. Let's see. 1440 divided by 9 is 16? Yeah. So 16 is equal to 4t to the 4/3. How do I solve for t when it's raised to a fractional power? Multiply by the reciprocal. Be more specific. Multiply what? So you want me to multiply by 3/4? Like that? That's not right. What do? You're right about the reciprocal. But what do you do with it? Yeah, you raise it to the power that is the reciprocal power. Because what are you trying to accomplish? What are you really solving for? You're solving for t to the first power. And then 16 to the 3/4 power is 8. So the answer is 8 months.